Everyone, today's lesson is an introduction to geometric proofs. So we're going to combine some geometric properties involving segments and angles and tie that in with the algebraic proofs that we did in the last lesson. So this is just going to help us ease our way into fully geometric proofs. And the first types of proofs that we're going to be doing are on segments and angles. So they're going to help prepare us for those. So first, let's start by going over some common justifications for geometric proofs. You are going to see a lot of the properties that we talked about with algebraic proofs. So using the addition, subtraction, multiplication, division, those properties of equality. And then we're also going to use some of these new ones. So we talked about the reflexive, symmetric, and transitive property for equality in our last lesson. Now we're going to use those properties with congruence. So it's the same exact idea. Instead of an equal sign, we're dealing with a congruence symbol. So for segments, that would look something like this, where we're saying segment AB is congruent to segment AB, or angle A is congruent to angle A. For the symmetric property, if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. And for angles, if angle A is congruent to angle B, then angle B is congruent to angle A. And finally, our transitive property, where we're saying for segments, if AB is congruent to CD and segment CD is congruent to segment EF, then we know that segment AB is congruent to segment EF, right? So that's that idea that we talked about where you're kind of cutting out that middleman. All right, this is a special type of substitution. With angles, if angle A is congruent to angle B and angle B is congruent to angle C, then we know that angle A is congruent to angle C, okay? So these we've seen before. We're just using that congruent symbol, all right, and that proper notation for segments and angles. Now, the definition of congruence is new, but it's going to be really important throughout this lesson and throughout the whole year for geometric proofs. So the definition of congruence tells us that if two segments are congruent, then we know their measures are equal. So if segment AB is congruent to segment CD, then the measure of segment AB is equal to the measure of segment CD. So here we're talking about the actual segments. Here we're talking about the measures of those segments. Okay, for angles, if angle A is congruent to angle B, then the measure of angle A is going to equal the measure of angle B. Okay, so when we're dealing with congruence, we're talking about the actual angle or segment. When we're using that equal sign notation, we're talking about the measure of that angle or the measure of that segment. Okay, and we're going to see right in that first example why this is so important. Our next postulate isn't new. That's our segment addition postulate. So if points A, B, and C are collinear and B is between A and C, then AB plus BC equals AC. So part of that segment plus the remaining part of the segment equals the whole segment. And the last definition postulate for segments that we're going to talk about is the definition of a midpoint. So if M is the midpoint of segment AB, then we know that segment AM is congruent to segment MB. Okay, now let's talk about angles. Our first is going to be the definition of complementary angles. So we know if two angles are complementary, so in this case we're talking about angles A and B, then the measure or the sum of the measure of those angles is going to equal 90 degrees. So we can say the measure of angle A plus the measure of angle B equals 90 degrees. Okay, for supplementary angles, if angle A and angle B are supplementary angles, then the measure, oops, I don't know why I put B first. The measure of angle A plus the measure of angle B is going to equal 180 degrees. And finally, our vertical angle theorem tells us if angle A and angle B are vertical angles, then angle A is going to be congruent to angle B. Okay. So our first two proofs are going to have the statements done for us, and we're just going to practice identifying what justification or reason we're using for each statement. So just like with our algebraic proofs, we have a given. We have a given. We have something that we're trying to prove. And in these examples, we're going to see we have a diagram. Okay, with algebraic proofs, we didn't have that. But from now on out, when we have two-column proofs, we are going to have a diagram that goes along with it. So in our given information here, it tells us that segment LM is congruent to segment NO. Okay, I see those tick marks are right on that diagram because I know already in my given they're congruent. And the measure of segment LM is 6x minus 7, and the measure of segment NO is 29. So my first statement is my given. Now, if I want to prove that x equals 6, I have an equal sign here. So I have to go from this congruence notation to equal sign notation. So if I know that these two segments are congruent, I know their measures are the same. Okay, so in step 2, I'm saying that the measure of segment LM is equal to the measure of segment NO, and that's my definition of congruence. Okay, the reason I needed to go into this equal sign notation is because if I want to solve an equation, I have to have an equal sign here. I can't have a congruent symbol. So I know that LM equals NO. I know that LM is equal to 6x minus 7. So where I see LM here, I'm going to write 6x minus 7. I know the measure of LM equals the measure of NO. And I know that NO is equal to 29. So where I see NO, I'm going to substitute in 29 there. So in step 3, we're just using the substitution property. Okay, now I have a two-step equation that I can solve here. So I'm going to add 7 to both sides. So this is my addition property of equality. And then in step 5, I'm dividing both sides by 6. My proof was that x equals 6. I have that statement x equals 6, so I know I'm done. Okay. Now, number 2 is using angles. So my given information is that angle R and angle S are complementary angles. The measure of angle R is 3x plus 7, and the measure of angle S is 6x plus 2. And we want to prove that x equals 9. So if I look at my first statement, that's all my given information. So I'm going to write given. Now, I know that angle R and angle S are complementary. So if those two angles are complementary, then I know the measure of angle R plus the measure of angle S equals 90 degrees. And that is by the definition of complementary angles. Okay. Now, the measure of angle R equals 3x plus 7. So where I see the measure of angle R, I'm going to substitute in 3x plus 7. The measure of angle S is 6x plus 2. So I'm going to substitute in 6x plus 2. So step 3 is just the substitution property. Okay, step 4, this is where I'm combining like terms. So if you remember from the last video, if you're combining like terms, even though I'm adding 3x plus 6x and 7 plus 2, I'm not adding anything to both sides of the equation. I'm just kind of cleaning up or simplifying the left side of this equation. So step 4 is not the addition property. This is, again, substitution. So anytime you're combining like terms, that is the substitution property. Okay? Between step 4 and 5, I'm subtracting 9 from both sides. So that's our subtraction property of equality. And then finally for step 6, to get x equals 9, that's our division property of equality. Okay, so now that we've done an example of a segment proof and an angle proof with our statements provided, all right, we're going to try 3 proofs where we have to come up with both sides. Okay? So for number 3, all right, we have our diagram on the right, and it tells us that M is the midpoint of segment XY, and that XM equals 7x plus 5, and MY equals 3x plus 25. Okay, so I'm going to write all of that as my given. And then my equals 3x plus 25. Okay, so step 1 is my given. Now, if I know that M is the midpoint of XY, okay, I can conclude that segment XM is congruent to segment MY by the definition of a midpoint. Okay, that was one of our common justifications that we were going to see, the definition of a midpoint. Okay, so I know that these segments are congruent, and as soon as I put that in my proof, when I write that as a statement, I'm going to put that notation in my diagram. I'm going to mark those as being congruent in my diagram. All right, now I know here I'm trying to prove that x equals 5, so I want to get into that equal sign notation. Okay, so I'm gonna say if I know that these segments are congruent, then I know the measure of segment XM equals the measure of segment MY. So that is our definition of congruence. Okay, and now I can use substitution. So XM is equal to 7x plus 5. My is equal to 3x plus 25. So this is our substitution property. Okay, and then we can start solving for x. So what I'm going to do first is subtract 3x from both sides. So I have 4x plus 5 equals 25. So that's going to be our subtraction property of equality. Then I'm going to subtract 5 from both sides. So that's my subtraction property of equality. Technically, yes, because you are subtracting 3x and you're also subtracting 5. You could kind of do that in one step, but I like to kind of do one thing at a time. And then I'm going to use my division property to divide both sides by 4. Okay, so the division property of equality. And I look, my proof is that x equals 5. My last step is x equals 5, which is exactly what I want, so I am done. Okay? All right, little typo I just want to change here. Okay, for number 4, we're going to try to prove that x equals 11. Okay, and we are given that angle ABC and DBE are vertical angles. The measure of angle ABC is 11x plus 9, and the measure of, oops, this is another typo. I'm going to have to go back and fix. EBD is 14x minus 24. Okay, now it's not always going to tell you that these two angles are vertical angles. That's something that when you're looking at a diagram, you should be able to conclude based on the diagram, but just because this is kind of an introduction, I did put that in the given, okay? So our first step is going to be to state our given information. So angle ABC and angle DBE are vertical angles. And the measure of angle ABC is 11x plus 9. And the measure of angle EBD is 14x minus 24. Okay, so that is our given information. Now, because I know that angle ABC and angle DBE are vertical angles, by the vertical angle theorem, we know that they are congruent. Okay, and that is by the vertical angle theorem. So because I've stated they're congruent, I'm also going to put that in my diagram. Okay, put those little arcs there. And just like what we saw before, because I know that they are congruent, I can then conclude that their measures are equal. And I need to know that their measures are equal in order for me to set up an equation to solve to try to prove that x equals 11. So step 3, I'm going from that congruence notation to equal sign notation by the definition of congruence. All right, so the measure of angle ABC is 11x plus 9. The measure of angle EBD is 14x minus 24. Here, this is my substitution property. And now we're going to start solving for x. So if I were to solve for x, I would subtract 11x from both sides. So this was my subtraction property of equality. Then I'm going to add 24 to both sides. So that's our addition property of equality. And then finally, I'm going to divide both sides by 3. So I get 11 equals x from the division property of equality, but that's not what we're trying to prove. We want to prove that x equals 11. So we're going to use that symmetric property to switch those sides. So our x comes first. Okay. All right, and our last one, number 5. So number 5, we know that AB is congruent to CD. Segment CD is congruent to segment EF. The measure of AB equals 7x minus 5, and the measure of EF equals 4x plus 4. So let's start by just listing our given information. And our reason is given. Now, one of the reasons I like to mark things off in my diagram, okay, if I mark off that AB is congruent to CD, I'm going to give those each one tick mark. And then if I said CD was congruent to EF, well, CD has one tick mark, so EF is going to have one tick mark. And then I can see that AB and EF both have one tick mark. So this is an example of that transitive property where I can say that AB is congruent to EF. And that's going to be helpful because here I only know those two measures. I don't know the measure of CD. So I can't really use that, but I do know the measure of segment AB and the measure of segment EF. So let's start by saying that segment AB is congruent to segment EF. That's by our transitive property. Okay, and then in step 3, AB equals EF. Okay, because thinking ahead, I know I'm going to have to do something with these two measures. like set them equal to each other. So this was my definition of congruence. Okay, so now let's use substitution. So AB is 7x minus 5, and EF is 4x plus 4. So that's substitution property. Next, I'm going to subtract 4x from both sides. So that would be 3x minus 5 equals 4. So we have our subtraction property of equality. All right, and just kind of moving along, I'm going to add 5 to both sides. So that's our addition property of equality. And our division is that x equals 3. Now, I'm trying to prove that AB equals 16. So I'm going to go back and say that AB equals 7x. For x, I'm going to substitute in 3 minus 5. So this is an example of our substitution property. Okay, because I took this part here, this AB equals 7x minus 5, and I just took that x and substituted in 3 because step 7 told me x equals 3. And then when I clean up the right side here, this tells me that AB is going to equal 21 minus 5, which is 16. So that's our substitution property. All right, AB equals 16 is what we were trying to prove, so we are all done with this proof. All right, so like I said, this was kind of just a little segue into the segment and angle proofs that we're going to do. Thank you so much for watching. If you have any questions, you can comment below. Thank you.